So we're going to summarize the end behaviors of any polynomial function. So it can fall under one category, one of four, I should say, okay? It's either going to be an even degree with a positive leading coefficient, an even degree with a negative leading coefficient, an odd degree with a leading coefficient that's positive, an odd degree with a leading coefficient that's negative. So when you have, there's something in common between even degrees, all odd degrees, and then there's something in common between all positive leading coefficients, all negative leading coefficients. So we're going to draw an example of each, and then we're going to write out what the end behavior is. So if it's an even degree, that means same direction, the end behaviors. If the leading coefficient is positive, then the right end goes up. So here's an example. Okay, we can't have any funky turns and whatnot. Here's an example of an even degree with a leading coefficient that's positive. And now we can just write out what the end behaviors will always be if it's an even degree polynomial with a positive leading coefficient. So the right end, which is as x approaches positive infinity, comma, y approaches positive infinity. As x gets more and more positive, your outputs, your behavior will be you go towards positive infinity. Your left end is talking about as x approaches negative infinity. What's the behavior there? Y approaches positive infinity. Both ends go up. If you have a leading coefficient that's negative, but you're still an even degree, both will go down. So the left end and the right end, we'll write it out. I always work on the right end first because your leading coefficient is dictating what your right end is doing. So as x approaches positive infinity, your output approaches negative infinity. And your left end, as x approaches negative infinity, your left end, okay, right? What is it doing? Your output is approaching negative infinity. Now, if it's an odd degree, your behaviors are going in opposite directions. If the leading coefficient is positive, then the right end is going up. So there's an example. So now we could just write it out so that you have the proper notation for any polynomial that falls in this category. So as x approaches positive infinity, what's y going to approach? Positive infinity. As x approaches negative infinity, okay, your y is going to approach negative infinity. And if you are an odd degree, but your leading coefficient is negative, that means the right end is going to go down. So it's going to look something like, okay, where the ends are the same. We don't really know about what's happening in the middle of the graph yet. We're going to learn about that next. So let's just write down our right end as x approaches positive infinity, y approaches negative infinity. Our left end as x approaches negative infinity, y approaches positive infinity. So your polynomial's end behavior will always be one of these four. Okay, so now I gave you four problems to practice. I gave you, not this time, instead of having the graph and then writing the information, you now have its equation. Remember, you need to make sure your equation is in standard form. You are worried about the degree and whether the leading coefficient is positive or negative. So number one, okay, A says, is the function an odd degree or an even degree? Okay. B is the leading coefficient positive or negative? And then C is you have to state the left end and the right end behavior. So first, what is the degree? So check, make sure, yes, it's in standard form. The degree is 8, right? That's the degree. So is this an even degree polynomial or an odd degree? This is an even degree. You don't just say even because an even function means something completely different. Now, is the leading coefficient positive or negative? Well, the leading coefficient is -4. So the leading coefficient is negative. So that means it goes in the same direction, your end behaviors, because it's an even degree. But since the leading coefficient is negative, that means that the right end goes down. So as x approaches positive infinity, y approaches negative infinity. And they go in the same direction. So if the right end goes down, that means the left end, as x approaches negative infinity, the left end must go down too. So that means y approaches negative infinity. Okay, number 2, g of x. If you look at your sheet, you can try these problems on your own. Pause the video, okay, try them on your own, and then play the video to make sure you got them correct if you'd like to do that. So this is in standard form, so the degree is 5, so this is an odd degree. Okay. Is the leading coefficient positive or negative? The leading coefficient is 13, that's a positive. So if it's odd degree, they go in opposite directions, the end behavior. Since it's positive, the right end goes up. So as x approaches positive infinity, y goes up, so y goes to positive infinity. The left end is saying as x approaches negative infinity, that means you're at the left end. What's your output going to be doing? It has to be doing the opposite of what y is doing here, so it has to be going to negative infinity. Number 3 is in standard form. So let's see, is the degree an odd degree or an even? 7 is the degree, so this is an odd degree. Is the leading coefficient positive or negative? The leading coefficient is negative 2, so the leading coefficient is negative. So that means opposite direction and behaviors, and the right end goes down. So as x approaches positive infinity, your y approaches negative infinity, and as x approaches negative infinity, your left end, y approaches positive infinity. And we've got one more problem, and then that is it for end behavior. And then we're going to make sure that when we graph, our end behaviors are graphed correctly. Number 4, r of x equals 7x to the 4th minus 2x to the 3rd plus 21x minus 1 Okay, so check. Yes, it's in standard form, so my degree is 4, so that's an even degree polynomial. Is the leading coefficient positive or negative? The leading coefficient is 7, so that's a positive. So even degree means they're going in the same direction. Because the leading coefficient is positive, that means the right end is going to be going up. So as x approaches positive infinity, now we say that the right end goes up, so that's y approaches positive infinity. The left end is as x approaches negative infinity. We just said that the even degree means they go in the same direction. So if the output is going up on the right, the output has to be going up on the left end as well. Okay, so that is it for end behavior of polynomial functions.